phenylpropanoids, flavonoids, and lignans. We are going to see the introduction about this particular classification of drug. Phenolic constituents are present in the vast group of plants. Phenolic group consists of at least one benzene ring with one or more hydroxyl group. Since they are present as glycoside or with sugar, they have aqueous solubility. Phenolic compounds can be categorized phenylpropanoids, phenol and phenolic acids, flavonoids, flavonols and flavones, xanthone, stilbene, anthocyanins, quinones, lignans, tannins. So in this particular presentation, we are going to see about the highlighted three categories, that is phenylpropanoids, flavonoids, lignans. Phenylpropanoids. Phenylpropanoids are naturally occurring phenolic compounds which contains three carbon side chains attached aromatic ring. So this is the three carbon side chain which is attached to an aromatic ring. They are biosynthetically derived from phenylalanine amino acid which contains one or more C6-C3 residues. And this is the structure of hydroxycinnamic acids. So para-coumaric acid, in this R2 position there will be a OH group. If OH group is present in R2 and R3, that compound is called caffeic acid. If R3 contains O-methoxy and R2OH, it is called as ferulic acid. If R1 is OCH3, R2 is OH and R3 is OCH3, it is called as synaptic acid. And the biosynthesis of para-hydroxycinnamic acid is through shikimic acid pathway. So this aromatic amino acids will form through shikimic acid, and thereafter it will be converted into cinnamic acid and then to para-hydroxycinnamic acid or coumaric acid. The other group of phenylpropanoids is the phenylpropenes, which contributes in volatile flavor and odor of plants. These phenylpropenes are isolated from plants in essential oil, that is volatile oil fraction, along with volatile terpenes. Next is flavonoids. This is the general structure of flavonoids, okay, which accounts for C6, C3, C6, C6, then 1, 2, 3, C3, then C6. Flavonoids are generally the compounds which gives color to the plant or responsible for plant pigmentation in the fruits, leaves and flowers. The yellow pigment of the plant is responsible for various flavonoids like aurones, chalcones and yellow flavonols. Chemically, flavonoids have the general structure of a 15 carbon skeleton which consists of two phenyl rings A and B and a heterocyclic ring C. This carbon structure can be abbreviated as C6, C3, C6. The most common flavonoidal constituents are rutin, quercetin, then hesperidin, naringin, etc. Hesperidin are commonly known as vitamin P or permeability factor, which is used in the treatment of capillary bleeding and capillary fragility. Then coming to the extraction procedure of flavonoids. Crude plant material is taken, which is extracted with boiling water, which gives a crude extract. Then addition of lead acetate, tannins are removed in the form of lead acetate, which has to be filtered. To the filtrate add water, then acidify with hydrochloric acid, boil for a few hours. Precipitate of sugar-free flavone and flavonoids we will get. Then to this add alcohol for extraction, then once again extract. Purification of compounds will be done by fractional crystallization or by recrystallization from organic solvents like benzene, carbon disulfide, alcohol, etc. Then this pure compounds will then be characterized using various spectroscopic techniques. Then chemical test of flavonoids, Shinoda test. Upon addition of few magnesium turnings and concentrated hydrochloric acid, drop by drop to the test solution, a pink, scarlet, crimson, red, or sometimes green to blue color develops after some time. Alkaline reagent test. When few drops of sodium hydroxide solution are added in the test solution, first sharp yellow color develops, which upon addition of dilute acid becomes colorless. Then zinc hydrochloric acid test. A mixture of zinc dust and concentrated hydrochloric acid is added in the test solution. It develops red color after some time. Then the third one, lignans. The lignan comprises a large group of polyphenols which mainly occurs in the plants. These are the example: enterolignans, entrodiol, and entrolactone. Plant lignans or polyphenolic substance which derived from phenylalanine via dimerization of substituted cinnamic alcohols, which is known as monolignol to a dibenzyl butane skeleton. This reaction is controlled by originated proteins and catalyzed by oxidative enzymes. Phenyl propanoids are buildup of C6C3 units, that is N-polybenzene skeleton, which are derived from cinnamyl units like as terpene chemistry build on isoprenoids. Similar to the formation of terpenes by building of isoprenoid units, here in this case polypropanoids builds so many units of polypropanoids will combine to form cinnamyl units or the lignans. Neolignan is a structure formed by condensation of phenyl propanoid units. In the absence of the C8 to C8- bond, where the two C6-C3 units are linked by a carbon-carbon bond, it is referred to and it is named as neolignan. The oligomers are resulted from condensation of 2 to 5 phenylpropanoid units. Nor lignans are specific to gymnosperm, which have C17 skeleton. Lignans are widely distributed among several families. The plant lignans, if taken in diet form, gets metabolized by intestinal bacteria to mammalian lignans named entrodiol, entrolactone. Lignans is the largest group of phytoestrogens, estrogen-like substance, which acts as antioxidant. These are the examples. Okay, this is entrodiol and this is entrolactone. Thank you.